Okay, Geometry, Chapter 6, Section 5, Conditions for Special Parallelograms. Pause the video and come back and check your answers. Number 1, find AB. For the point A and point B, you should have 5. Number 2, find the slope. You know how to find slope, and you should have -1. ABCD is a parallelogram, so justify the statement that angle ABC is congruent to angle CDA. And you should have said, if you have a parallelogram, then opposite angles are congruent. Number 4, angle AEB is congruent to angle CED. Vertical angles theorem. Good. So today the objective is to prove that a given quadrilateral is a rectangle, rhombus, or square. So we're going to start with conditions for rectangles. You can use these theorems to determine whether your parallelogram is a rectangle. So theorem 651, if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. Okay, so remember with parallelograms that they are supplementary with their adjacent angles. So if angle A is 90 degrees, angle B must be 90 degrees, and angle D, and so forth. So we have one right angle is all you need to know for your parallelogram. We have theorem 652, which states if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So congruent diagonals let us know that we have a rectangle. Remember, with kind of the classic slanted parallelogram, one diagonal is shorter than the other, right? Good. So let's see if we can apply this in a carpentry application. A manufacturer builds a mold for a desktop so that length AB is congruent to side CD and BC is congruent to DA. And measure of angle ABC is 90 degrees. Why must ABCD be a rectangle? So we know that when opposite sides of a quadrilateral, both pairs of opposite sides in a quadrilateral are congruent, we have a parallelogram. Good. And then we know that if we have a parallelogram and one angle is 90 degrees, we just learned in our first theorem that all angles then must be 90 degrees, or we have a rectangle. Good. And let's take a look at 3 conditions for rhombuses. Rhombus. Remember that all sides are congruent in a rhombus, right? So the first condition, the first theorem, 653, if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So we have a parallelogram and one pair of consecutive sides, in this case EH and EF, are congruent, then the parallelogram is a rhombus. 654 says if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Good? And 655, if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So the diagonals are angle bisectors in rhombus, right? Good. So be careful. In order to apply these theorems that we've talked about today, the quadrilateral must be a parallelogram. So that's a key part of the given information. Then you can apply these theorems. To prove that a given quadrilateral is a square, it is sufficient to show that the figure is both a rectangle and a rhombus, right? And that will come up in exercise 43. Remember, you can also prove that a given quadrilateral is a rectangle, rhombus, or square by using the definitions of the special quadrilaterals that we've already learned. Okay, so in this question, determine if the conclusion is valid. If not, tell what additional information is needed to make it valid. So we are given segment EF is congruent to segment FG, and we are given that EG is perpendicular to FH. So these feel like the theorems that we were just talking about. Consecutive sides are congruent and diagonals are perpendicular. So can we state that EFGH is a rhombus? Unfortunately, we can't. And why can't we? What is the reason we can't? Hopefully you're thinking, we do not know if this quadrilateral is a parallelogram, right? So by these theorems, if we knew that this was a parallelogram, EFGH, this quadrilateral, I don't know why they say ABCD here, that's an error, right? But if we knew that was a parallelogram, then the given information is enough for us to state that EFGH would be a rhombus. But we needed that information that was not given. Okay, next question. Determine if the conclusion is valid. If not, tell what additional information is needed to make it valid. So here we have, once again, a quadrilateral, EFGH. Now we're being told that EB is congruent to BG, FB is congruent to BH, EG is congruent to FH, and EBF, triangle EBF, is congruent to triangle EBH, EBH. So the question is, the conclusion is, EFGH is a square, okay? So this first step is, can we determine with this given information that EFGH is a parallelogram? And we can. So how can we? We know that we have diagonals which are being bisected. So we can say that EB is congruent to BG and FB is congruent to BH, which tells us, that's given, which tells us that this is a parallelogram based on the fact that quadrilaterals with diagonals that bisect each other are parallelograms. So we have now stated that this is a parallelogram. So the next step would be to determine if it is a rectangle. So is there enough information here to determine that this is a rectangle? And we can say that EG is congruent to FH, right? There we go, EG and FH, okay? And so it is a rectangle because parallelograms with diagonals that are congruent are rectangles. And finally, can we determine that it is a rhombus? Let's look at it. Here's the information. Rhombus, all sides congruent, right? And so we know that it is a parallelogram. We know that it is a rectangle. And so EF is congruent to EH. EF and EH based on our congruent triangles, right? And so we know that consecutive sides of a rhombus, when we have consecutive sides of a parallelogram that are congruent, we have a rhombus, and that's exactly what we have here. Consecutive sides are congruent in this parallelogram, so we have a rhombus. Very good. And so now, can we state that it is a square? How can we do that? Let's see. Since it is a rectangle and a rhombus, that was enough information, right? For us to know that we have 4 right angles and 4 congruent sides, so it is a square by definition. The conclusion is valid. Very good. And let's see. Next example, identify special parallelograms in the coordinate plane. We're asked to use the diagonals to determine whether a parallelogram with these vertices given is a rectangle, rhombus, or square. Give all the names that apply. So the first step would be to graph this parallelogram PQRS. There we have it. And the next step might be to find PR and QS. PR and QS, let's see, P is -1, 4, R is 4, 3. probably should label those, and determine if PQRS is a rectangle. I'm going to go back and label these vertices. You can do that too. Okay, so there we have the labels. That's better. So we're going to see if PR is congruent to QS. If they are congruent, we can say it's a rectangle, right? So let's see. How will we find the distance here? It is we're going to use our distance formula, right? It's the hypotenuse of a right triangle. Same is true for QS, right? We'll have to imagine that hypotenuse. So use your distance formula, and when you do, pause, come on back, see if you agree with me here. And look at that. We have both of them, PR and QS, are square root of 26. Since they are equal, these diagonals are congruent, and so we could state that PQRS is a rectangle. Now, we are supposed to see also if it is a rhombus or square. Okay, so how will we determine whether it's a rhombus? Well, we had a couple different ideas. Let's look at it again. One would be to determine that consecutive sides are congruent, right? So that might be one way. Let's see if that's what's used here. Oh, they're using something different. Okay, another theorem states that if our diagonals, which we just found are the same length, are perpendicular, let's look at it, if the diagonals were perpendicular, then we would have a rhombus, right? So we can find the slope now. The slope of PR would be what, down 1 and over 1, 2, 3, 4, 5, so negative 1/5, and the slope of QS would be up 5 and over 1, so 5 is negative 1/5 perpendicular to a slope of 5, and I'm sure you're saying yes, right? So we can say that this is a rhombus due to the fact that the diagonals are perpendicular. And finally, because we know that PQRS is a rhombus and PQRS is a rectangle, we can state that PQRS is a square. See if you can answer this question in our lesson quiz. Pause, come back and check it out. Okay, we know that these segments are equal in length. What other information is needed to conclude that this is a square? Well, if we could find that AC is equal, right? Equal to the other diagonal BD, then we would know that this is a square. So if segment AC is congruent to BD, we would know. Good. And the next question, determine if the conclusion is valid. If not, tell what additional information is needed to make it valid. Given PQRS and PQNM are parallelograms, segment MN is congruent to segment NR. Can we conclude then that MNRS is a rhombus? And the answer is yes, it is valid. Think about how this would be a transversal, right? MN. So M and R, SR would be a transversal. We would have a lot of congruent angles in addition to congruent sides. So opposite angles would be congruent here. Definition of a rhombus, good. And part 3, use the diagonals to determine whether a parallelogram with these vertices is a rectangle, rhombus, or square. Remember, we found that the diagonals were equal to prove that it was a rectangle, and we found that they were perpendicular to prove that it was a rhombus. So go ahead and test that out and see what you come up with. I hope you have taken the time to graph this, and when you do, you have noticed that the diagonals, unfortunately, are not congruent in this case because they are not, it is not a rectangle, nor is it a square. But the question is it a rhombus? So if you take those diagonals and test their slopes, they are negative reciprocals, and so we could say that ABCD is a rhombus. Good job. Okay, and finally here is your assignment for today. Good luck, have fun, enjoy.